Imagine gazing up at the sky, not to see just the moon and stars, but an ethereal arc stretching from horizon to horizon, a celestial crown adorning our planet. What if Earth, our familiar blue marble, suddenly sported a magnificent ring system, rivaling the splendor of Saturn's? This isn't just a flight of fancy, it's a profound thought experiment, transforming our world in ways both breathtakingly beautiful and scientifically fascinating. From the bustling streets of New York to the ancient pyramids of Giza, from the serene beaches of Bali to the vibrant markets of Tokyo, the rings would dominate our visual landscape. During the day, they would appear as a delicate shimmering ribbon, reflecting sunlight with varying intensity depending on our position on the globe and the sun's angle. Think of them as a permanent, iridescent cloud formation, constantly shifting in subtle brilliance. They wouldn't be a uniform band, rather a series of distinct rings, each with its own texture and subtle coloration, visible even to the naked eye. As the sun dips below the horizon, the spectacle would amplify. Sunsets would be utterly revolutionized. Instead of the sun vanishing into an empty sky, its light would filter and refract through the ice and rock particles of the rings, painting the sky with unprecedented hues of orange, red, and violet. This celestial diffraction would create dynamic, ever-changing patterns, a daily masterpiece. The rings themselves, catching the last rays, would glow with a soft, otherworldly luminescence, casting long, dramatic shadows. But the rings wouldn't just be a visual marvel, they would fundamentally alter our planet's environment, particularly its climate. Due to the angle of Earth's tilt, the rings would cast colossal shadows across vast swathes of the planet. Regions directly beneath the ring plane, especially near the equator during certain seasons, would experience extended periods of darkness each day. Imagine cities perpetually under a cosmic eclipse, where daylight hours are significantly reduced. This constant shading would lead to a noticeable drop in average temperatures in these areas, fostering cooler, perhaps even colder, microclimates. Conversely, areas that remain exposed to direct sunlight for longer periods would experience subtle warming trends. These ring shadows wouldn't be static. As Earth orbits the sun and the planet rotates, the shadow bands would sweep across continents and oceans, creating dynamic weather patterns. We might see an increase in fog and localized precipitation in shaded regions due to reduced evaporation, while unshaded areas could experience drier conditions. This would inevitably reshape ecosystems. Forests accustomed to direct sunlight might struggle, while new, shade-adapted flora and fauna could thrive. Agricultural practices would need to adapt dramatically, with new crops and farming techniques emerging to cope with altered sunlight cycles. The rings, in essence, would become a colossal, planetary-scale parasol, unevenly distributing the sun's energy and sculpting new, unique climates across the globe. As day gives way to night, the rings would transform once more, becoming a glowing beacon in the darkness. Illuminated by the sun from beyond the horizon, or reflecting earthshine, they would cast a soft, ambient glow across the landscape, reducing the need for artificial lighting in many areas. The night sky, already a source of wonder, would be profoundly enhanced. While the rings might obscure some distant stars, their own breathtaking presence, coupled with the faint glow they cast on our world, would create an entirely new kind of celestial beauty, a constant, luminous arc against the cosmic tapestry. Scientifically, Earth with rings would become an unparalleled laboratory. Studying their composition and dynamics up close would revolutionize our understanding of planetary formation and ring systems across the universe. New scientific missions would launch, not to distant gas giants, but to our own backyard, gathering data from the ring particles themselves. This proximity would offer unprecedented opportunities for material science, potentially even harvesting rare elements from the ring fragments. Culturally, the rings would permeate every aspect of human life. They would inspire new art forms, music, and literature, becoming central to our myths and legends. Imagine architectural designs incorporating the ring's perspective, or calendars organized around the movement of the ring shadows. Global tourism would explode around ring viewing locations, turning certain cities into prime astronomical destinations. Humanity's perspective on its place in the cosmos would be irrevocably altered, fostering a deeper connection to the universe. However, such a magnificent adornment would not come without its challenges. For spacefaring nations, the rings would present a formidable obstacle. Launching satellites or crewed missions would become significantly more complex and hazardous. Navigating through a dense field of icy and rocky debris, even if microscopic, poses a constant risk of collision. Orbital trajectories would need to be meticulously calculated, and spacecraft would require enhanced shielding. Entire new technologies would emerge to safely traverse or avoid the ring plane, fundamentally reshaping the future of space exploration from Earth. Our immediate celestial neighborhood, once relatively clear, would now be a dynamic, debris-filled environment. Despite these complexities, a ringed Earth would undeniably be a more beautiful and fascinating world. From the spectacular, daily light shows in the sky to the unique climate sculpted by their shadows, and the profound impact